Hello and welcome to today's web conference. This is Fast Track Dynamics 365 for Finance and Operations Enterprise Edition Tech Talk. Today's topic, Monitoring, Optimization Advisor, and Critical KBs. Presenting for us today from Microsoft, we have Chief Product Architect Jakob Steen Hansen. Joining Jakob, we have Group Engineering Manager of the Supply Chain Team, Kostas Kastrinogiannis. And rounding out our presenter group, we have Director of Engineering, Lamego. So without any further delay, Jakob, over to you.
Thank you, Janice. In this context, it's key that one of my responsibilities is that I have the team that operates the cloud service. So this is dear to my heart. And today we recognize that, of course, to successfully run critical business systems, we need to enable each of us to effectively do what we're responsible for. The success of what we do comes easier when we're operating in unison. And that requires trust and transparency. So we've created this session aimed at providing transparency to how we aim at playing our part of how we operate the systems in the cloud. So the objective of the talk is to introduce how we monitor and how tools like Optimization Advisor and the uptake of critical KBs will help us all run the systems well. We'll also provide an understanding of what monitoring is and how that information that we collect live is being put into actions. And at the end, we're going to cover how to quickly engage with Microsoft when something bad happens, despite all the efforts we all do to keep the system running well. What we're not going to cover is support processes, SLAs, communication protocols. Again, this is aimed at providing transparency to what we do in areas that have not been that easy to get access to. So as we do that, we're going to talk about monitoring. Andre is going to take care of that, and Kostas is going to take you through what we call the Optimization Advisor and the importance and the means for applying the critical KBs. And then I'm going to return and talk about how you report a production outage, what that really is and what it isn't. But let's dig into monitoring. Andre, please.
Hello, everyone. My name is Lamego. I'm Director of Engineering for the Foundation Group in the platform. One of the components that is under my scope is the monitoring, the healing aspect of the components, of the core components of the system, namely the OS, the batch engine, and the other components that we all know well. So the goal for this monitoring session is to kind of showcase all the spots in our pipeline of components and applications where we collect the data, how we use the data, and how that data allows us to invest in healing solutions, how those healing solutions help us making sure that the system is running smoothly and continuously without interruptions. So I will also give an overview, or in order to explain monitoring better, I'll give an overview of our servicing. And our servicing understanding our servicing is key to understand how we really interact with our monitoring and the data collected by such monitoring and the alertings built on top of this monitoring. And in specific, I will go into the coverage of the watchdog, which is a component, one of the components that we have that's designed and tailored specifically for the detection and the automatic resolution and the proactive monitoring of the system. So from the servicing overview, let's start with the most basic scenario where the customer connects to their instance of the FNO that request comes from the client, from the FNO client, and it goes through our load balancer to figure out what is the closest and most available instance that can reply to the request. Our FNO instances can be of multiple kinds, so it can be an AOS, a private AOS, a VI, and they're composed of a list of services, some interactive services such as AOS, reporting, or SSIS. They also have background services or background operations such as batch and database synchronization, which we use for servicing. This is not a comprehensive list, but it's just examples of what or what each of our instances are composed of. Our service, our FNO service, doesn't run in isolation. It connects to external services to provide the functionality that we use. For example, 3 of the services that it connects to is SQL Azure, Power BI for embedded reporting, and Azure Storage for document handling. These are, again, it's not an extensive list, but it's just examples of the services we connect to. The interesting point is, and this is represented here with a little star, the interesting point is at multiple points inside the instance and outside the instance, we have telemetry being captured. We have signals from each of these components being emitted that represents the operations throughput, that represents the signals of health, the state, and what sort of operations are they executing. And that data is collected by a process we run on every instance called monitoring agent. That agent is collecting all these signals and transmitting these signals through a pipeline that collects signals from other role instances within the same cluster, within the same region, collects all these signals and transmits it to our telemetry storage, where we store these signals that we've collected. So the little star outside of the instance is what we call outside in, and what the stars inside of our instance we call inside monitoring. So with our emission of signals, actually before I get there, our partner and our partners and administrators of the system can access that telemetry storage through LCS environment monitoring. That's a special page in LCS that connects directly to the telemetry storage and provides the partner or administrator the view of the health state and the operation state of each of the components that we have in each of the instances. So at every spot that we collect data, aggregate data, transmit data, or store the data, we deploy a series of monitors. Okay, so if the data that we emit is towards the health state, but we monitor that health state to making sure that it's under our range of acceptable values. And within those monitors, we have the capabilities of raising alerts. So when something goes outside of boundaries or something is not expected, something is not normal, we raise a ticket. And the way we raise a ticket is through our incident management system. Okay, so we have an incident management system where all the tickets raised by our monitoring are processed and handled. Just a note that our partner and administrator through LCS is able to directly create tickets in our incident management system. And Jakob will cover that towards the end of this presentation. So once this ticket is created, our Microsoft engineers on call, they acknowledge the ticket, they start working on the ticket, and in order to get an understanding of what might be going wrong, or what is the component that is not responding, or something like that, they have access to the telemetry storage. So the data that we collect about the health state of the components is stored in telemetry storage. Our engineer on call has access to this telemetry storage. Once the knowledge about the health state is once the engineer on call knows about what to do, he will apply corrective actions against our role instances. We'll restart the components, restart the instance, we'll apply the appropriate fixes, etc. We'll apply the corrective actions. Okay? So what we have is a system that we call the watchdog. It's a system that is able by itself, it's an autonomous system that is able by itself to collect and handle these signals and also apply corrective actions immediately. Kind of a bot that we are able to collect the actions and collect the signals, measure, assess the health state, and apply corrective actions for the things that are well prescribed. So Watchdog can do. Watchdog is a component that we also put into our role instances and is shipped through continuous delivery. We're always updating this Watchdog, always updating its capabilities. So the Watchdog contributes to our proactive monitoring of the environment by taking the right actions and taking the actions before there is even a ticket. Once the knowledge about the health state is understood to be at fault, it can do the corrective actions. This doesn't end here. So after the ticket is mitigated means that the issue is immediately resolved. There's a series of follow-up actions after each ticket, which we call repair items. Okay? The repair items can be of multiple kinds, can be a code fix to the platform to make sure that the next versions of the product do not enter this error state again. Can be a hot fix, meaning that we are actually patching existing versions of the product and rolling out this patch. Can be new healing actions on top of the watchdog. So if the ticket was created by an administrator or a partner, or was created through a monitoring system that is able to be, whose mitigation is able to be automated, we will turn that into watchdog actions. We can deploy as a repair item, we can deploy new telemetry to help us understand further what can be causing a component to be unhealthy, or new metrics saying, let's detect better when it's unhealthy or faster when it's unhealthy. And those metrics are accompanied with new monitors and alerts, so that once we have the tools to detect faster when something is unhealthy, more quicker we can get a ticket on us so we can engage. Okay, so this is in general how our servicing is orchestrated. This is very, very high level, not too much on detail, but the importance is that it goes very, very tightly correlated with our monitoring. So our monitoring and our telemetry and our servicing are very, very tightly correlated here. More specific about Watchdog, it's deployed in our role instances, so it takes care, it handles the health state of our components that are deployed in the role instance. And some examples here, the AOS, the batch, MR, some of the retail components, SSIS, monitoring agent, and other healing components such as itself, such as Watchdog. So what sort of capabilities can the Watchdog leverage in order to understand the health state of the environment? Well, it can read resource utilization encounters from different components within the role instance or in the associated services. For example, it can read these counters from SQL, from the Azure SQL database, where the AX connects to. For example, DTU utilization, transaction log, tempdb, those are all emitted as counters that Watchdog can leverage in the assessment of the health state. Okay, it can read data from the VM, such as memory, CPU utilization, port utilization within the role instance. Can read system and process information, like what is running on the box and how frequent that is running, and so on. Can read instrumentation data, so data emitted by any of the components running on that instance. Can read configuration data, so the data that's configured in the system that's stored in the database That's one, but it can also read configuration of the system in files. Like, for example, the configuration of the AOS is a file on disk that can be read by the watchdog. Can read package data, so the data that's of the different components, different versions of the platform, different versions of the application that are deployed. It can access that. It can read SQL data for data integrity issues. And it can read general ETW data of the environment, not necessarily from our components, but it can read ETW data of the system. For example, did Windows Update kick in? Did the environment, is the environment under stress over a particular series of requests, and so on. It can read data from the environment in general. So with a lot of data and combining these data feeds, it can do actions, and those actions can be quite intelligent. So let's start with the most basic action. Watchdog can create tickets, tickets that Microsoft engineer needs to go in and address. Okay, so when something is wrong and the watchdog cannot fix it, he will create a ticket so an engineer can go and address. Through this, data feeds can actually augment the data that exists on telemetry. So, for example, if a version of the product did not have the appropriate telemetry for us to diagnose a problem, but the watchdog, as we continuously deploy it, can augment such data. So the next time there is an incident, we can be more efficient at resolving it. It will do so. It can augment the data in the incident tickets to facilitate the resolution. And so whenever watchdog creates a ticket, it can actually put the right set of data in the ticket or linked by the ticket so that the engineer on call has very, very quick engagement on the problem, and can do actions of the type restarting the component, triggering requests to the component to make sure it responds in the appropriate time and authenticates in the appropriate manner, can do corrections to the configuration and corrections to the environment. Okay, so yeah, so this is kind of this watchdog tool is the one that helps us the most with proactive engagement, and this is a big bet from us in the foundation group. So now I'm going to hand over to Kostas to discuss, to show the optimization advisor, which is a great tool on the X++ side of the world. So you take it, Kostas.
Thanks, Andre. Let me start sharing my screen so that I can do a few demos on the way. I'll continue right where Andre left it. To start with, I'm Kostas Kastrinogiannis, Group Engineering Manager of the Supply Chain Management Team, which is an application group within F&O. I wanted to speak a little bit about the Optimization Advisor. I'll start from an introduction to our main aspiration and goal, which is that if an incident happens, let's make sure that it happens only once. So we're trying to learn from those incidents and make sure we understand the preconditions of them. And as Andre mentioned before, understanding those preconditions might allow us to auto-heal some of these problems. That's why we start working on self-healing loops like the watchdog. Those self-healing loops have three main characteristics. The first is how they diagnose. Do they diagnose a problem based on signals from telemetry, or do they diagnose it based on a state in the data? A second dimension is how do they heal a problem? Is healing including restarting a component? Is healing about deploying a hotfix? Is healing about fixing the data? The third dimension is who is the person that actually has the authority or owns the action. Is it Microsoft? Is it a partner? Is it a business user? We started working on the Optimization Advisor to serve the incidents that the diagnosis is on business data, the solution is on business data, and the person responsible for taking action is actually a business user owning that particular business process. So what we ended up doing is having this healing loop, the optimization advisor, built within the product, because then it can actually be closer to the business users, give them the insight of what is the opportunity to improve, and help them take action. And many of these actions are automated. The business user only has to click a button and get the problem solved. So the optimization advisor runs as part of AOS as a batch job. It has a list of rules, each rule being responsible for detecting a problem, and if the problem is detected, then suggest a way to mitigate it. And each rule is speaking directly to the business users that own the relevant business processes. The user experience is within the product, and that's what I'd like to show you right away. So now I'm within F&O, and if I scroll down, I can see the optimization advisor workspace. I have already pinned the impact and opportunity tiles on the front page so that I can very quickly see what is relevant. If I navigate within the optimization advisor, the first thing that you'll see is a list of opportunities to improve. For all these opportunities, I can get more information. I can take action directly. I can hide from my list because it's not relevant for me as a business user, or I can completely deactivate the analysis because it's not relevant for my organization. There is a large set of opportunities out of the box for different modules and business processes of the product. I'll see one as an example. Let's take this one, configure pre-closing to optimize inventory closing. So inventory closing is a process that can take a long time for a company, and many times would like to optimize it. Part of this optimization is pre-processing data in time so that we don't have to do it right at the time that inventory closing starts. And this is where the optimization advisor suggests to take that action. And we can even quantify what is the expected gain if the business user decides to take that action. So every time a user clicks more information on an opportunity that has a rather generic title, then the optimization advisor will pull all the data of the diagnosis and try to quantify the opportunity for the improvement. On the second tab, we see a list of impact that was generated due to business users taking action. So imagine that a business user decided to take in the past the action to optimize inventory closing. Then the optimization advisor will assess whether the impact was what was expected, and if that happens, then we'll inform the relevant business user. In that case, the optimization advisor will say that you configure pre-closing as a separate batch job on that date, and the processing time was reduced to that amount. So the advisor has the ability to keep doing diagnostics after an action has been taken to assess the impact and inform the business user. Switching back to the presentation. As I mentioned before, based on our experiences with incidents and things that went wrong on business data through time, we have already defined a list of opportunities and optimization advisor rules out of the box. For instance, we've seen cases where the batch job history table grows, and when that happens, we create an opportunity to make sure that our customers are setting up the periodic cleanup job. We had incidents that the scheduling engine within MRP was failing to find the right reservations because the resources were running out of calendar days. When we detect that, we let the relevant business user know. There have been cases that invoices have been locked for payment, and again, we detect that and we let the right business user know about it. And the list keeps going. I wouldn't go in detail here. I hope that you'll be able to find the opportunities on different environments and take actions based on that different case. I would also welcome partners and customers to build their own opportunities and build their own rules within the optimization advisor. This is Next++, and it is fairly simple to create another rule. Based on experience, it takes maximum a day or two to build another rule, and each rule, in essence, does a few things. It has some text that allows it to communicate opportunities and the details of those opportunities. It has a diagnostics query that is against the tables of F&O, and it usually has an automated action that enables the business user to heal the problem right away. I would separate the different rules in three categories to drive some inspiration within your teams. The first category of rules is about optimizing configuration, setup, master data. These are the examples that I showed as well, and I would imagine that you might have in mind other rules for what is shipped as part of standard F&O, but as well as extensions and customizations that have their own configuration that might need optimization from time to time. The second category is about optimizing a business process itself. Not about optimizing the system, make it more performant, but optimize the actual business process. An example that I will give here is coming from MRP. MRP relies on static lead times to calculate a plan. These lead times are in production, like in operations that take some time to set up and run. Those lead times also exist within procurement master data with regards to how much time does it take from a particular vendor to get some goods in-house. If these static master data are outdated, that means that MRP calculates an inaccurate plan. But the optimization advisor could recurrently check the difference between the actual transactions and what is in the master data. And when this difference is high, then you can suggest adjusting the master data to reality. You can go as wild as you wish, because the optimization advisor can call an ML function that does forecasting and adjusts these lead times based on a forecast and have them accurate through time. A third category of rules is optimizing recurrent activities. Many times there are business users that have to make sure that a state of the product will be always there. For instance, that there are no invoices that are pending for more than a month. Instead of having the business user checking every day, if that's the case, there can be a rule within the optimization advisor that does this check, and if a business user should be notified, get the notification directly. With that, I'll jump into the critical KBs, which is another healing loop with slightly different purpose. I mentioned the three dimensions: how do we diagnose, how do we heal, and who owns the fix. In the case of the critical KBs, the diagnosis is on telemetry, and the fix is with a particular KB that we have already released. The person that owns this action is either the IT department of our customer or a partner supporting that process. The problem that we're trying to solve here is that we've been many times in the unfortunate situation that we have a critical incident like data corruption or very slow performance, and the problem is already fixed and the fix is already released for the right version, but is not deployed on the environment of the customer. As you can imagine, this is very unfortunate, because the only thing that we can do is try to mitigate the problem and make sure that the KB is deployed. But if that had happened a week ago, then the incident would have never happened. So what we do now is we analyze telemetry of production environments to detect if particular customers are in pain due to problems that we have already solved. And if that's the case, then we'll suggest the critical KB for that particular customer. So it's not that we have a flag behind the scenes that when we make a critical KB, it becomes critical for all customers and all production instances, like we used to do in the past. Instead, critical KBs are individual for each production instance because we are based on our analysis on telemetry coming from that production instance. So this healing loop lives within LCS. Recurrently, it analyzes telemetry, identifies potential problems that we can see in customers, and if we have already solved these problems, then it will suggest the right KB. So let me show you how that looks like within LCS. So now I'm on Life Cycle Services, and I'll select an environment. And you can see that I have a tile called Critical X++ Updates. This tile has zero critical KBs right now, and I hope that this will be the state for every production environment we have live out there. That means that if you are in the situation where you don't see a zero on your critical KBs, most likely you'll have to take it as a priority to go and deploy those KBs, because they would prevent data corruptions that we would know that you are in risk, or optimize the performance in a way that it will avoid outages. Through critical KBs, usually we also deploy additional telemetry if we know that there is a problem, but we're still not sure what is the root cause of that. With that, I'll give it back to Jakob to continue with his part on production outages. Jakob, is all yours.
Thank you, Kostas. And as I hope it's clear, a lot of things are happening for us to keep the systems in a good shape, and some of the responsibilities are involving you as application owners. But with all the monitoring and with all the optimization advices and with the critical KBs, things can still go wrong. And we've introduced the concept of reporting a production outage through LCS to ensure that if you struggle with a critical business impacting issue in the production environment, you can get to our operations engineers really fast. So let me go to this one. And the production outage is a situation that prevents the business from continuing. It's an issue where someone needs to do something immediately. And in popular terms, it can cost whatever it needs to cost. Just get it back now. So it is an immediately arising situation that prevents performing one or more critical business processes. The system might be inaccessible, or whatever you do, it just leads to errors. It can be one or more instant or business critical processes that just stopped working. And the point here is stopped working. It's not that they never worked. It's, as I started, an issue that needs immediate resolution to avoid critical business impact. Those are true production outages, and when any of those occur, you go hit what we refer to as the big red button and report a production outage on LCS. I also want to make clear what a production outage is not, and that's back to my initial point on if we each play our role and do it well and create the transparency and leave room for every one of us to do our best job, success comes easier. Which means if you use a production outage reporting for the right things, we will do a better job. So what a production outage is not a problem where we can fix it anytime. Yes, it's important, but it's not really truly critical this second or minute to fix it. And it's not some discovery of a functional problem. So a production outage is not just an issue with a feature in the system. It's not something that was suddenly discovered not working and has never worked. It's not if we can take our time to solve it beyond the hour. It is not a production outage if it needs a ton of coordination, because it's actually not as important as other things that are going on right now. It's not a slow operation or a general performance issue. That's not a production outage. The system will still work. It will work slower, and yes, it has impact, but the business doesn't break. It's not if it's a mistake or an error that causes a delay in implementation. And it's not a way to escalate an already reported problem or issues with dev and sandbox. We have customer support with report for critical issues, with a very fast reaction time, and those should be used for everything that isn't a production outage. Because when a production outage hits, which means when someone pushes that big red button, it's immediately going out to the customer support. So an MS Solve ticket, a ticket in the customer support is created, and a live incident operations team is onboarded right away. So they engage within the minute, looking at signals from the systems, debugging where necessary, collecting information, tweaking and correcting, looking at infrastructure, looking at software. Frequently, with all the monitoring that Andre went through, we know of the problem already when the production outage report comes in. So engineers are already working on it. When customer support engages within the first 30 minutes, customer support will get in contact with the customer so that we can tie a connection between what's going on at the back end and what the customer is experiencing, and keep everybody in the loop on what's going on. Frequently, it's necessary to get some elaboration on what is the problem actually. So the customer support agent is going to be the connection there. When the problem is identified as a truly critical problem and we can't mitigate it sufficiently quickly, we will also engage communication. So there's going to be regular updates back to the customer on what's going on, what do we need, when do we expect things to change. And that sort of takes us full circle. We've talked about the monitoring and the vital role it has in keeping us all aware of what's going on and in making the automated auto healings, the corrections to known issues, the optimization advisor that helps us set up systems correctly and keep them running smooth, and the critical KVs that allows us to get the fixes for observed issues, either in that particular environment or in other environments that we know will affect the environment, getting those applied. And then I just went through the outage reporting. And that all concludes what we wanted to run through today. So we are ready to take questions.
All right, thank you, Jakob. All right, ladies and gentlemen, as Jakob mentioned, we are going to move into the Q&A portion of our call today. If you'd like to ask a question, go ahead and type your question into the white text box and click send, and our team will address those as they come in. While we're waiting for those, I'd like to bring your attention to a link that I posted in that messages panel. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference, have feedback on how we can provide you with a better event, or you'd like to submit topics for future web conferences, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. I'm going to go ahead and come back over to our Q&A panel. I'm not seeing anything there at the moment. Gentlemen, do you have any final thoughts while we wait for some of those comments to come in or before we wrap up?
No, I think I got my fair share.
All right. Okay, well, I'm not seeing any questions come in, so with that, we're going to go ahead and wrap this session up. That's going to conclude today's web conference. Attendees can access the web conference recording via the same registration link used to attend today's live broadcast. I'd like to extend a big thank you to our presenters, Andre, Jakob, and Kostas, and thank you, audience, for logging in and joining us today.